All right, we got sound. We're good. All right, so this is for y'all, calculus. Uh, Finish your notes up. I've got a hard copy up here too. If you'll pay attention, I'm loading hard copies of stuff. It may not be the exact same set of notes, but it's a copy. It's probably pretty darn close. It's an old copy. But let's finish these notes up. And when you start talking about your hyperbolas having the y-axis transverse axis, notice that the equations are a little bit different. It's reversed. That should make some sense if you think about it. But we're going to graph this one. And you see the word analyze, it just means graph. That's all it means. So I know that a squared is 4. So a is 2, right? There's an understood 1 under that thing. So I know that b is 1. It's time to figure out what c is. So I do b squared equals c squared minus a squared. And I just plug stuff in. And if I'm going too fast, I'm trying to do this during lunch break. So just hit the pause button. Okay. 1 squared equals 2 squared minus, oh, did that backwards. 1 squared equals c squared minus 2 squared. As a surprise, just like every other example that we've done, we're going to get c squared equals 5, and c is plus or minus the root of 5, which we already know is about 2.23. Surprise. For some reason, I think all the ones in these notes are about like that. And I think we have everything to figure this out. Because this is the big guy. This is an up-down. You know, this is an up-down situation because A is big and it's under Y, and Y it starts with Y. So we know all that. So our vertexes are right here and right here. We have two vertices. Now I'll write that off to the side. Now it would be proper if you said you had vertices at 0, 2 and 0, negative 2. Let me get this out of the way. It's causing some screen time up there. And C is like 2.23. So here's C, and there's C. You have foci. Now, when I do the ordered pair, I'm going to go back and use roots of 5 at 0 root of 5 and 0 negative root of 5. The approximation of the decimal is just to give me a good idea of where to place it. Remember that B is 1. And it's not really a vertex anymore. It's kind of telling us how to draw our box. So we're going to go out 1. And we're going to draw our box. I actually have some disagreement with how they draw this box, but that's just me. And anyways, through there passes our slant asymptotes. I think that these are really accurate close, but I think as you move on to infinity that you lose some detail. Because this box is suggesting a slope of rise 2, run 1. And we know it's a little bit more than that. So I kind of have an issue with the whole box out technique. I think it's just meant for close. I don't think it holds out here in infinity. But, you know, this is introduction. This isn't exact science. And mine are not supposed to do that. They're shifting up. They're not. They're supposed to kind of flatline towards the asymptotes. And I don't know why I'm putting anything there. Probably ready to get out of this room. And there she is. She's analyzed. Now, I'm not going to bore you with the next one. I am going to show you, you know, one thing, and then I'll let you take it from there. But your form here is supposed to be either x squared over a squared minus y squared over b squared equals 1, or y squared over a squared minus x squared over b squared is 1. Now, you kind of have a good idea here that it's x squared over something, but we'll see what happens. We'll see what happens. Something might be not quite right with this thing. We're going to divide through by 36. Now when I divide 9 by 36, I get 4. When I divide 4 by 36, I get 9. And that's 1. Well, maybe I mentioned something wrong here. I did mention something wrong. This is still in the form of a left-right. X squared is positive. This is a left-right. Leads with x squared. It's a left-right. I might have had a little confusion between when I taught you in class between ellipses and hyperbolas, which happens. I can't recall everything on site. So leads with x squared. So it's a left-right. So you just go back and look at your notes. Now, here's the things that we do depending on if we're parallel to which axis, x-axis or left axis. And it works a lot like with ellipses, how I taught ellipses. There's a lot of other stuff in here that's going to throw you off. The slant asymptotes is kind of cool. Notice that they use point slope form. You'll have to zoom in on your notes. Kind of got blurry on this one. But notice they use point slope form for slant asymptotes. That's kind of cool. They also have some stuff in here talking about how you find the foci and the vertices. You don't have to memorize this. You just have to know that when you draw, it's about the relationship to the center, okay? About the relationship to the center. So that's the big deal. And H and K have and always will be centers of graphs. That's what they are, centers of graphs. Sometimes we call them a vertex, but when you've got two figures, it's a center. Or it's a circle. It's a center. I've got some bleed through on this pretty bad, so I'm going to get a fresh copy. So find an equation of the hyperbola with the center at 1, -2, focus at 4, -2, and one vertex at 3, -2. This is not supposed to be in here. Evidently I typed it in one year and I forgot to erase it, but it's there, so use it. But definitely start by graphing. We have a center to the right 1 and down 2. There's my center. We have a focus at 4, -2. To the right 4 and down 2. There's a focus. We have a vertex at 3, -2. Now everything there, and that's what this note's about, the center, the focus, and vertex are on this line y equals -2. So the transverse axis is parallel to the x-axis because this thing is going to be opening so that it eats the focus. Okay? It opens so it eats the focus. Now, if you have a focus at 4, -2, and you have a center at 1, -2, these guys are 3 units apart. You have another focus that is 3 units to the left, okay? And I'm kind of lining this up for good reason. 4 minus 3 is 1. 1 minus 3 is -2. I have another focus at -2, -2. Some kids don't need to do that, some do, but there's another focus. And talk about your vertex. You have a vertex given at 3, -2. You have a center again at 1, -2. And just kind of look at the pattern. You have another vertex. 3 minus 1. 3 minus 2 is 1. 1 minus 2 is -1. So there's your other vertex. Some things that are given to us. The focus gave us the letter C. The center gave us the letter A. And now we just need to find B. And it seems like with these that B squared is C squared minus A squared. So we'll just plug that in. All right, so where was I? B squared is 4 squared minus 1 squared. That's 16 minus 1. B squared is 15, and B is plus or minus a root of 15. Now, that means that from the center, I go up a root of 15 and I go down a root of 15. So the actual ordered pair here, if I was to actually show my ordered pairs, there would be no change on x. It'd be 1, and it would be negative 2 plus a root of 15, and then 1 and negative 2 minus a root of 15. Now on your graph, you just need to approximate that decimal and get as close as you can. The root of 15 is really close to 4, really close. So I'm going to go to a calculator. It's not one of these that I have any idea. It's like 3.9. And I'm just going to go to the nearest tenth. So negative 2 plus 3.9 is 1.9. And negative 2 minus 3.9 is negative 5.9. And those are points that I can plot. You know, I can get really close. So I need to go really close to 2 units above the center. I don't know why I drew this thing all the way up to 4, but it's about right in that neck of the woods. And I need to drop. Sorry, I did need to go up to that. I need to get close to 2, don't I? Because it's about relationship to the center. I'm almost 4 units above the center. And then I need to drop really close to negative 6. 3, 6, just right there. Now remember, the box that you draw is between the B points and the vertices. And that's going to give you your slant asymptotes. And the slant asymptotes here, because this is not centered at the origin, they pass through the center of the hyperbola, not the origin. And then you draw. These are actually fairly wide parabolas. And that's how that's done. Now, I'm running low on time. I would love to do the lightning strike example with you, but the bell's about to ring. There is one on your homework. There is. Kind of refer to this layout. That's going to tell you everything you need to know. On that homework problem, take the information, put it on a graph like this, and figure out what you can figure out, okay, kids? But I'm going to stop right there. This didn't take you too much of your time. So you've already got the homework sheet. If you're not here, it's posted, okay? You can do it. And I will see you Friday, God willing.